Hello, I am Mrs. Vishali Chaudhary. Today we are going to explain chemical bonding, and when chemical bonding occurs, what is the nature changes will take place and different substances are properties of matter. We know we are surrounded by different matter surrounding us. What are that matter? Any substance is called as a matter. They are basically the three types: solid, liquids, as well as the gaseous one. Three main states of matter: solid, liquid, and gaseous. But when we are talking about the engineering, we are focused on the solid. In solid, particles are closely packed. They cannot move from each other. Why they are not able to move? Because they are closely packed. It is have a fixed shape, difficult to change. They have a definite volume. Here we will observe molecules difference. In the first case, small molecules are attached with each other, compactly binded with each other, having a definite shape and a volume. They are not occupying whole space in the container of the container. They have a fixed shape. They are not taking the shape of container. Next one. All these molecules are scattered here and there. They will take shape of a container, but they are slightly higher attractive force than a gaseous state. So they are going to join with each other and they are not easily moving with each other. But in case of the gaseous, all molecules scatter here and there. So they can take the shape of container and whatever the space available, they will occupy that. Classification of the solid is done on the basis of whatever the molecules are present and the structure of molecules. Firstly, they are divided into two categories: amorphous solids and a crystalline solid. If molecules are arranged randomly, they are called as amorphous solids. If molecules are arranged in a particular order, it is called as crystalline solids. Crystalline solid again divided into the four types: covalent or network solid, metallic solid, ionic solid, molecular solids. We already learned about the covalent bond, metallic bond, ionic bond. So covalent compound shows the covalent solids. What are the covalent compounds? No. Yes, you have to remember this. Metallic solids, what are that? All metals are the metallic bonds, metallic solid. Copper, gold, silver. Ionic solid. What is the example of ionic solid? Yes, namak, table salt, sodium chloride. Molecular solids. Covalent solid again divided into two categories: two-dimensional, three-dimensional. Molecular solids, polar solid, non-polar solid, hydrogen bonded solid. Classification is based on how the molecules are arranged in which order molecules are arranged. Did you see crystalline structure and the amorphous structure? In a crystalline, all are arranged neatly one by one, having showing one type of structure. But amorphous solid, just like you students sitting at home randomly looking here and there. Crystalline solids are called as true solid. Amorphous solids are called as Pseudo-solids or the supercooled liquids because they are not have a fixed shaped dimensions. That's why they are also called as supercooled liquids. Geometry. Crystalline solid particles are arranged in a repeating pattern. They have a regular and ordered arrangement resulting in a definite shape. What is meaning of that? Did you observe the sodium chloride common salt? They are having a crystalline structure. All crystal is having a definite shape. That's why they are called as crystalline structure. They are following particular pattern. That's why they are called as crystalline solid. Amorphous solid. Particles are arranged randomly. They do not have an order arrangement, resulting in a irregular shapes. Melting point. Due to the difference in the geometry, their physical property is going to differ. In a crystalline solid have a regular arrangement, that's why it is having a sharp melting point. Amorphous solids, they don't have a sharp melting point. They are softened gradually over the temperature range and then after converting into the liquid state. Did you observe the candle wax? Yes, when we are heating it, it started melted slightly. First it will become soft. After that it will be converted into the liquid form. That is called as a range of a melting point. Crystalline solid. See, the particles are having a neatly arranged in a particular order. Example is table salt, common salt. They are called as true solids. Minerals are the true solids. Minerals, metals are the true solids. Atoms, ion, molecules are arranged in an order and symmetrical pattern that is repeated over the entire crystal. They are incompressible, meaning they cannot be compressed into smaller shapes. Just look at the structure. Do you observe all the particles are compactly attached? So there is no free space in between. So even after pressing from any direction, they are not able to get compressed, remain as it is. They are having the distinct melting point. Having the same structure, they require same energy to convert from the solid state to the liquid state. Therefore, same melting point, and that is the amorphous solid. Example is glass, rubber. Glass. When we are heating the glass, it is going to become soft. Then after it is become melted completely. They are called as pseudosolids or the supercooled liquid. They do not have repeating lattice pattern or repeating particle size. Glass, rubber, gels, mostly plastic, wax. It's called as amorphous solid. They don't have a definite melting point. They melt gradually over the temperature because bonds do not break at all at once. They are soft, malleable state before returning to liquid state. Classification of the crystalline solid. Crystalline solids are classified into four categories on the basis of intermolecular attraction between the molecules. They are molecular solids, covalent or network solids, ionic solids, metallic solids. How we are going to differentiate different metals as per the structure? For that, we have to first learn crystal lattice. Crystal lattice is a three-dimensional representation of atoms and molecules arranged in a specific order or pattern. It can be defined as geometrical arrangement of atoms, ions, or molecules at point in a space. There are total 14 possible three-dimensional lattice. Among following, which is an amorphous solid? Options are diamond, glass, sodium chloride, none of the above. Diamond is having a particular crystal structure, so it is a crystalline. Glass. Molecules, atoms are arranged randomly. Melting point is different, so it is having amorphous. Sodium chloride, crystalline structure, so answer is glass. The sharp melting point of crystalline solids is due to crystalline solids have a sharp melting point. Why? Because they are having regular arrangement of a constituent particles. So what different arrangement of constituent are wrong. Same arrangement of constituent particles in different direction. Regular arrangement observed over long distance in the crystal lattice. A regular arrangement of constituent particles observed over short distance in the crystal lattice. You have to read answers properly, all options properly, then have to decide. Next time we are going to learn about the crystal